Section 3.5 is on systems with three variables. In the previous sections, we took a look at systems of equations that had two variables, and to solve those we needed to have two equations. But you can also have a system of equations with three equations that have three variables. As we saw with a system of two equations, it can have one solution, no solution, or infinitely many solutions. Since the graph of a two-variable equation is a line, the graph of a three-variable equation is actually a plane. And here's a diagram from your textbook that shows a little bit about what that looks like. There's no way I was going to try to draw this one. So what you're looking for ideally is, or if there is one solution, then the three planes are going to look like this, and they intersect in one common point right there in the middle. Okay? If there's an infinite number of solutions, then the planes intersect something like this in a line. So that line represents an infinite number of x, y, and z coordinates that lie in all three of those planes. And there's three situations where you can have no solution. You can have three parallel planes. You can have two planes that are parallel with one kind of cutting through them. Or you can have something that, like this, that looks kind of like a three-dimensional triangle. So, to algebraically solve a system of three equations, we're going to use elimination and substitution. One of the equations will need to be used twice, and the solution to a system like this is called an ordered triple. That's an x, a y, and a z coordinate. So let's take a look at an example here. And you'll probably notice that I've devoted a whole page to this. It does kind of take a little bit of work here. So here's our system of equations. You'll notice that there's an x, a y, and a z. And the trick to doing this is to take two of the equations and eliminate one variable, and then choose two other equations and eliminate the same variable. Looking at this system, I'm really liking the looks of z. Because notice I have a negative z, a positive z, and a negative z. I think I'm going to try to eliminate z in these equations. Oops. I'm going to eliminate, that's an m, okay, my z. So to keep the equations straight, I kind of like to label them. I'm going to call the first one a, the second one b, and the third one c. And I think what I'm going to start with is, notice that if I add a and b, I'll eliminate z. So let me move this down just a little bit more here. Get a little more space here. Perfect. Okay, so I'm going to do a plus b, and that's going to give me 3x plus y minus z equals 1. That's a, and I'll put b right underneath it. And just as I did with two variables, I'm going to add these two equations, and I get 4x plus 3y, notice my z's get eliminated, equals 5. And I'm going to call that equation D. Now I need to use two other equations, so I could use a and c, or I could use b and c, and I need to do it in such a way that I eliminate z from those two. So I'm liking the look of b and c, so I'm going to add b plus c, and that's going to give me this. There's b. Let's put c right underneath it. And when I add those two equations, my z's are eliminated, and I have 4x plus y is equal to 7. And I'm going to call that equation E. Now, I want to take a look at D and E together, and notice they both have an x and a y, and I want to eliminate now either the x or the y like we did several sections ago. And so I think what I'm going to do is, I think I'm going to do D minus E. So D was 4x plus 3y equals 5, and I'm going to subtract 4x plus y equals 7. So 4x minus 4x is going to be 0, 3y minus y is going to give me 2y, and 5 minus 7 is negative 2, so y is equal to negative 1. Okay? I'm 1/3 of the way there. But actually it gets a lot easier from here, because now I just have to substitute. So I'm going to take this value for y right here, and I think I'm going to plug it into that equation there. So I have 4x minus 1 is equal to 7. 4x equals 8, or x is equal to 2. 2/3 of the way there. Now I'm going to take those two values and I think I'm going to plug them into, I think I just chose equation B because it had all pluses in it. So now I'm going to take those two, put them into B, and I will get 2 plus 2 times -1 plus z is equal to 4, or 2 minus 2 plus z equals 4, or z is equal to 4. So my final answer, let me scroll down just a little bit here, is going to be the ordered triple 2, comma -1, comma 4. Line them up x, y, and z. And there's my solution. You could check this by plugging them back in if you want to. So I have another example here, which I'm not actually going to go through. I've actually already done it. Another example of a system of equations and 3 equations, how to solve it. I did this one in advance because I didn't want this video to be as long as some of the previous ones, but just if you'd like to look at another example here. I decided in this one that I was going to eliminate x because I don't know, sometimes if I don't have a preference, I'll just go for x. So I added a and c, which made sense since I had x's there, a positive x and a negative x. And then I had to multiply equation c by a 3 in order to use b and c to eliminate another x. And I got an equation in y and z, an equation in y and z. And I decided to keep d the same as it is here and multiply this by a -3 in order to eliminate z's, which happened nicely here. So I got down to y equals 2, plugged that into d to get what my z is, and then plug them into a to get my ordered triple. So if you'd like to take a look at this and work through it as another way of example, that's great. But here's the really cool part. We have a word problem that uses a system of 3 equations. Okay, you're an office supply distributor and you budget $7,200 for 80 office chairs. So that's really important. You have a total of $7,200 and you're buying 80 office chairs. You can buy leather chairs for $125 each, mesh chairs for $100, and fabric chairs for $75. And you want to have 3 times as many fabric chairs as leather chairs. How many of each type of chair should you buy? Let's start by defining some variables. I'm not going to use x, y, and z because I'll get confused. So I'm going to say let L equal the number of leather chairs. Let M equal the number of mesh chairs. And let F equal the number of fabric chairs. Okay, so I know that I am buying 80 office chairs. It's down a little bit. So that means that L plus M plus F is equal to 80. I also know that leather chairs cost $125. Mesh chairs cost $100. And fabric chairs cost $75. And altogether, I'm going to spend $7,200. Okay, now my last equation comes from where it says you want to have 3 times as many fabric chairs as leather chairs. So the number of fabric chairs has to be 3 times the number of leather chairs. Okay, so I think I'm going to start by eliminating F. In order to eliminate F, I am going to substitute. I forgot to label these. Let's label these. So let's make that one A. Let's make this one B. And we'll make this one C. Okay, so I'm going to substitute C into A. And when I do that, I'm going to get L plus M plus 3L. I put in 3L for F. Gives me 80. Or 4L plus M is equal to 80. and I'm going to call that equation D because I'm going to use that one. Now let's use A and B to eliminate F. So I think what I'm going to do next is I'm going to multiply A times negative 75, and I'm going to add that to B. So if I multiply A times a negative 75, I'll be eliminating my F's right here. So that's going to give me negative 75L minus 75M minus 75F is equal to negative 6,000. Negative 75 times 80. And I'm going to add to that just my second equation, 125L plus 100M plus 75F equals 7,200. And when I add those, let me slide this up a little bit, I get 50L plus 25M, those get eliminated, is equal to 1,200. And I'm going to call that equation E. So now I have an equation with an L and an M, and another equation with an L and an M. And I think what I'm going to do next is try to eliminate, I'm going to eliminate my M's. So I'm going to do negative 25 times this equation, and that'll take care of that. So negative 25 times equation D plus equation E. So multiplying this by a negative 25 gives me a negative 100L minus 25M equals negative 2,000. And I'll add to that my equation E from over here, 50L plus 25M equals 1,200. Adding those together, give myself a little more room here. I'll have negative 50L is equal to negative 800, and dividing both sides by negative 50, I get that L equals 16. So 16 leather chairs. Let's substitute that into equation D up here. So that's going to give me 4 times 16 plus M equals 80, or M is equal to 16. And let's take both of those, and I'm going to substitute that into A. A was my cool equation that basically said L plus M plus F is equal to 80. So F is equal to 48. So what am I going to buy here? I'm going to buy 16 leather chairs, 16 mesh chairs, and 48 fabric chairs. And that gives me my total of 80 chairs and for a cost of $7,200. So in this section, we took a look at systems of equations with three variables, with an x and a y and a z, and how to solve those by elimination and substitution.